Looking now at section 4.2, which is volumes of revolution around the y-axis, and hopefully you'll remember from the Core Pure 1 book that if we have a function like this, from y equals a to b, and we rotate it around the y-axis, then the way to do that is integrate x with respect to y, integrate x squared with respect to y, and then times the answer by pi from a to b. And that will give us that volume of revolution around the y-axis. Why do we need to have a whole extra section on it? Well, again, the function that we're integrating might not be a nice function, and as happened in the Core Pure 1 book, we're not usually given y in terms of x. So if we have this function 4 times natural log of x, take away 1, then that is y plus 1 divided by 4 equals natural log of x. So x equals e to the y plus 1 all over 4. So to find this integral, and in this question they're asking us to go from y equals 0 to 4, we'd have to do the volume that we want is the integral, so pi times the integral from 0 to 4 of e to the y plus 1 over 4 all squared with respect to y. Now that rearrangement, getting x in terms of y, sometimes is easy, sometimes is difficult. This integral sometimes is easy, sometimes is difficult. So if your integration is in need of a practice, then practice that before you are attempting this chapter and make sure it's really smooth. And that's all there is to say, really. So for people that want it, I'll run through a little bit more of this example. But it shouldn't be too tricky. I suppose I should mention as well, if they give you, as they have in question 1, x in terms of y straight away, well, that's fine. You can just take that expression, square it and integrate it. That's not too much of a problem. You've got to watch out for them being sneaky. Let's see if I can find an example of a question. I can't see one easily, but here they've given us the y values to integrate between. Sometimes they will give you the x values from x equals something to x equals something else. And in that case, you obviously need to convert those into y values to make them into the limits on your integral. So watch out for that. Those are the usual traps. What would we do here? Well, I think we'd think of it like this. Y plus 1 over 4, but we're squaring this whole thing. So this exponent is going to become y plus 1 over 2 with respect to y. And then that's going to be pi times the integral from 0 to 4. I'm going to think of this as y over 2 plus 1 over 2. So this integral is the integral now of e to the y over 2 plus a half. So e to the y over 2 times e to the power of a half. And all we're using here is indices rules, isn't it? We're not really using anything fancy. It's just, you know, the AS Blue Book chapter 1 or 2. E to the half is a constant, so it can come out the front of my integral. E to the y over 2 with respect to y. So pi e to the half. E to the y over 2 integrates to e to the y over 2, but I need to adjust because of this constant, so 2 lots of that from 0 to 4. And that's, well, from there, I really think you can finish it off for yourself with the help of the blue box on page 81 if you would like to. So that is section 4.1 and 4.2. Good luck with those.